Tonight, if you look up at the sky and choose one of the faintest points of light, take a moment to realize something extraordinary. The light you are seeing may have begun its journey long before humanity ever existed. We often take pride in the fastest spacecraft we have ever built, moving at speeds of over 17 kilometers per second. But in this vast, dark ocean, that speed feels like a slow step, almost insignificant. If you had begun a journey at the moment our ancestors first drew on cave walls, travelling through thousands of years of history up until this very second, you still would not have covered even 1,000th of the distance to the nearest neighbouring star. The true vastness of the universe is not in the numbers that make us feel small, but in something deeper, that no matter how far the distance, we continue searching for a way to reach it. Right now, the Voyager 1 is still sending back faint signals from more than 24 billion kilometres away. And far beyond that, the latest observations from James Webb Space Telescope in 2026 are opening doors to ancient cosmic structures, places where reality itself begins to blur into the unimaginable. Welcome. This is Space Lull. We believe that every number out there, no matter how cold or distant it may seem, carries a story about where we come from. Stay with us, not just to measure the universe, but to feel the quiet connection between this small, beating heart and the vastness beyond. As always, I'd love to know where in the world you're listening from and what time it is where you are. And don't forget to subscribe to Space Lull so you don't miss the latest videos. Let's begin. Let us begin our journey from the most familiar place, our home. In textbooks or the visual models you often see online, the solar system appears crowded and vibrant. Planets glow brightly, placed close together, orbiting a radiant yellow sun. But the truth is, every one of those images is misleading your eyes. If a model were drawn to scale, the planets would be so small you wouldn't be able to see them, and so far apart that the distances would feel almost unreal. At its most fundamental level, the universe is not made of matter, it is made of emptiness. At the centre of that emptiness lies the sun. Imagine it as something vast and insatiable. It contains about 99.8% of the total mass of the entire solar system. Everything else, from massive gas giants like Jupiter and Saturn to microscopic dust, and even us, accounts for only the remaining 0.2%. Scattered remnants left behind after the formation of that star. If we shrink the sun down to the size of a basketball, our Earth would be nothing more than a tiny grain of sand sitting about 25 meters away. Neptune, the most distant planet, would be a speck of dust more than a kilometer from that basketball. And the space in between? There is nothing there, only darkness, and a silence so complete it feels absolute. We often think of the distance between Earth and the Sun as something immense, about 150 million kilometers. Astronomers call this 1 astronomical unit, or AU. To make it more relatable, if you were driving a car at 100 kilometers per hour without ever stopping, it would take you around 170 years to reach the Sun. And yet, in the scale of the universe, 1 astronomical unit is barely a single step. As we move beyond the warm region of the inner planets and past the asteroid belt, space begins to stretch in a way that feels almost unsettling. By the time we reach Neptune, we are already about 4.5 billion kilometers away from the Sun. At that distance, the Sun is no longer a glowing disk warming your skin. It shrinks into a sharply bright, distant point, cold against the black sky. Even light, the fastest thing in the universe, takes more than 4 hours to travel from the Sun to this frozen world. But Neptune is not the end. Many people assume that once we pass the planets, we have left the solar system. In reality, we are only standing on the front step of our home. Far beyond the orbit of Pluto lies the Kuiper Belt, a region filled with icy bodies and dwarf planets drifting in perpetual darkness. And even farther still, surrounding everything, is the Oort cloud, a vast spherical shell containing trillions of icy objects, marking the outermost boundary where the Sun's gravity can still hold on to something. The Oort cloud may extend as far as 100,000 astronomical units, nearly 2 light years. If you stood at its outer edge and looked back toward the center, our Sun, the source of all life on Earth, would appear as just another ordinary star. No brighter, no more remarkable than millions of others scattered across the Milky Way. Out there, the idea of day and night no longer exists. There is only existence itself, suspended in the void. And the farther we travel, the clearer a paradox becomes. The solar system is not defined by its planets, but by the vast spaces between them. Spaces so immense, so deep, that they seem capable of swallowing human imagination entirely. Matter is rare. Emptiness is the rule. We are living on a small fragment, drifting in an ocean of space so vast that our presence within it feels almost improbable. Pause for a moment. Between these billions of kilometers and distant regions we've just crossed, can you feel that silence? When you look at the structure of the solar system and see Earth as nothing more than a colourless grain of dust within the immense reach of the Oort cloud, do you still feel that we are at the centre of something grand? Or are we simply fortunate enough to have found a warm place to rest in an endless, silent desert of space? As we leave the outer boundary of the Oort cloud and move into interstellar space, familiar units like kilometers or miles begin to lose their meaning. They become too small, like trying to measure the distance between continents using the length of a grain of sand. To truly understand the scale of the universe, humanity had to rely on something far more fundamental, something woven into the fabric of reality itself: light. Light is the fastest thing in the universe. In a vacuum, it travels at approximately 300,000 kilometers per second. To put that into perspective, in a single blink of an eye, light can circle the Earth about 7.5 times. If you could move at that speed, you would reach the moon in just over 1 second. On Earth, light feels almost instantaneous. You turn on a lamp, and the room is illuminated immediately. But once you step into the vastness of space, that incredible speed begins to reveal its limits. Light is no longer instant. It becomes something else, a patient traveller, moving steadily across immense darkness. The distance from the Sun to Earth is about 150 million kilometres. Light takes 8 minutes and 20 seconds to make that journey. This means that if the Sun were to suddenly disappear right now, you would still see it shining in the sky for more than 8 minutes. We never see the Sun as it is in the present, we only see it as it was a few minutes ago. Because the universe is so vast, scientists use the distance light travels in 1 year as a standard unit of measurement, called a light year. Despite its name, a light year is not a unit of time, but of distance, an immense one. It equals approximately 9.46 trillion kilometers, a number so large that if you tried to count every kilometer, 1 per second, it would take you nearly 300,000 years just to finish counting. And this is where the true scale of the universe begins to overwhelm us. Our solar system, with all its grandeur, spans only about 2 light years if we include the outer edge of the Oort cloud. But the moment you step beyond that boundary to reach the nearest star, Proxima Centauri, the distance jumps to 4.24 light years. Pause for a moment and think about that. The closest neighbouring star, the one sitting right next to us in our galactic neighbourhood, is so far away that light itself, the fastest thing in existence, needs more than 4 years to get there. If Proxima Centauri were to explode tonight, humanity would have to wait over 4 years just to see the light from that event reach our eyes. When we look deep into space, we are not seeing the present, we are looking into the past. This is one of the most important insights in modern astronomy. The night sky is not a snapshot of the present moment, it is a layered record of history. Some of the stars you see shining may have already died millions of years ago, their final light still travelling toward us. In space, distance is time. The farther away something is, the deeper into the past we are looking. Light becomes a messenger, carrying ancient information. It does not just tell us where something is, It tells us what it looked like when our own world did not yet exist. At larger scales, the slowness of light becomes almost painful to comprehend. To cross the Milky Way, light requires about 100,000 years. To travel from the nearby Andromeda galaxy to us, it takes about 2.5 million years. In this vast universe, light, the very symbol of speed, begins to feel slow, like a traveller crossing an endless desert. Every piece of information we have about the universe is limited by the speed of light. We are like inhabitants of a distant island, receiving messages in bottles sent millions of years ago. There is a quiet loneliness in that realization. Even if another civilization existed just a few hundred light years away, and they sent us a signal right now, it would take centuries for it to reach us. The universe seems structured in a way that prevents instant communication, isolating each star system, each galaxy, into its own island within an ocean of time. Light gives us a way to measure the universe, but it also reveals the boundaries we cannot cross. It reminds us that no matter how far human knowledge advances, we are still bound by the rules of a universe far greater than ourselves. Look into the darkness between the stars, where light must travel for years, centuries, or even millions of years just to pass through. Can you truly imagine a distance so vast that even the fastest thing in the universe seems to age along the journey? And when you realize that every point of light above you is a portrait of the past, where do you feel you stand within this endless flow? The truth is, light does not only show us how big the universe is, it quietly warns us about something else. A journey between the stars that humanity may never truly be ready to take. And if light is our measuring tool, then is everything within its reach truly all that exists? We are about to move deeper into interstellar space, where the numbers begin to stretch beyond ordinary logic. As we leave behind the last icy remnants of the Oort cloud, we officially enter a new domain, interstellar space. This is a region of near total emptiness. There is no sunlight to provide warmth, no atmosphere, and almost no significant matter. Only the quiet presence of sparse hydrogen atoms drifting across distances that the human mind evolved to navigate just a few kilometers simply cannot grasp intuitively. To understand the severity of interstellar distances, consider Voyager 1. Launched in 1977, it remains the farthest human-made object in history. It is travelling at over 60,000 kilometers per hour, a speed that, on Earth, could take you from Hanoi to London in under 10 minutes. And yet, after nearly 50 years of uninterrupted travel, Voyager 1 is still only just beyond the edge of our solar system. If its destination were the nearest star system, Alpha Centauri, it would require another 70,000 years to arrive. 70,000 years. That is roughly 14 times the entirety of recorded human civilization. By the time such a journey is completed, humanity may have evolved into something entirely different, or perhaps no longer exist at all. This reveals a crucial insight. The greatest barrier we face is not propulsion technology, but time itself. The universe appears to impose a kind of isolation on intelligent civilizations. The average distance between stars in the Milky Way is about 5 light years. Imagine attempting to send a simple "hello" message to a civilization on the opposite side of the galaxy using radio waves, which travel at the speed of light. That message would take 100,000 years to arrive, and if they replied immediately, you would wait another 100,000 years to receive the response. From the Stone Age to the age of artificial intelligence, the entire arc of human history is just a brief moment compared to the time required for a message to cross the galaxy. Even if the Milky Way were filled with intelligent life, each civilization would remain effectively isolated, confined within its own star system by invisible, unbreakable barriers of time. Interstellar space is not a road, it is a vast, dark ocean, where each star is a distant island, separated by trillions of miles. This emptiness is so extreme that even when galaxies collide, the chance of 2 stars actually crashing into one another is nearly zero. They simply pass through each other, like ghosts drifting across an empty stadium. This sparsity protects us, but it also confines us. We stand on a small grain of dust, looking outward and dreaming of journeys to distant worlds. Yet the reality of physics reminds us that crossing interstellar space requires more than faster ships. It may demand an entirely new understanding of space and time. As we move deeper into this void, every concept of near and far begins to collapse. Here, even a light year becomes just a small marking on an endless scale. We are drifting within a reality where silence is not merely the absence of sound, but the absence of presence itself. And in this vast darkness of interstellar space, where even light must travel for years to reach its next destination, do you believe that a human, life barely lasting a century, could ever truly complete an interstellar journey? Or are we meant to remain distant observers, watching those shining islands through telescopes, accepting our place as solitary witnesses? The truth may make us feel small, but recognizing these distances beyond intuition, is the beginning of a deeper understanding of the universe. Because what we have just encountered is only the first layer of isolation, and beyond it lies something even larger, the true structure of the immense system we call the Milky Way. If the journey through interstellar space left us feeling isolated in darkness, then in this chapter, we begin to realize something very different. We have never truly been alone. We are part of a vast, luminous city, more vibrant and dynamic than anything the human mind can easily imagine. Welcome to the Milky Way, a colossal home that holds the entire history, breadth, and future of humanity. From Earth, on quiet, dark nights, the Milky Way appears as a faint, misty band stretching across the sky. But if we could step outside and look back at it from afar, that band would transform into a magnificent spiral of light and dust. The Milky Way is a barred spiral galaxy, a vast, disk-like structure spanning about 100,000 light-years in diameter. To put that into perspective, if our entire solar system were reduced to the size of a coin, the Milky Way would be as large as a continent. Within this continent of light, there are not just millions or billions, but between 100 and 400 billion stars. Each one is a sun, and data as of 2026 suggests that most of them host at least one orbiting planet. That means there could be trillions of worlds scattered across these spiral arms, waiting, silently, to be discovered. There is a simple truth that our intuition often fails to grasp. You are never truly standing still. At this very moment, as you sit or lie quietly listening, you are part of an extraordinary motion. The Earth orbits the Sun, but the Sun itself, along with all of us, is being carried along in a much larger flow. The entire solar system is moving through space at an astonishing speed of about 220 kilometers per second. At that speed, we are traveling over 800 times faster than a commercial jet. Every second, you move the equivalent distance from Hanoi to Vinh. Every minute, more than 13,000 kilometers pass beneath you, unnoticed. We are participating in a vast cosmic dance around the center of the galaxy, a journey astronomers call a galactic year. To complete just one orbit around the Milky Way's center, the Sun takes about 225 million years. The last time Earth occupied this exact position in space, early dinosaurs had only just begun to appear. Humanity did not yet exist. We are travelers aboard a massive rotating system, a vessel called the Milky Way. So what holds all of this together? What keeps hundreds of billions of stars from drifting into the endless void? The answer lies at the heart of the galaxy. At its center, hidden behind dense clouds of dust that visible light cannot penetrate, lies Sagittarius A star, a supermassive black hole with a mass about 4 million times that of our Sun. But this black hole is not a devouring monster, as often portrayed in fiction. It acts more like a gravitational anchor, shaping the structure of the entire galaxy. Around it, stars move at incredible speeds, thousands of kilometers per second, creating a region that is both brilliant and chaotic. We are fortunate to be located far from that center, in a relatively calm region known as the Orion Arm, about 26,000 light-years away. Far enough to remain safe, yet close enough to be part of this immense system. When we look at the Milky Way, we begin to see a remarkable hierarchy. Earth is a grain of sand within the solar system. The solar system is a faint point within the Orion Arm, and the Orion Arm is just a small segment of the galaxy's sprawling spiral structure. Most of the stars you see in the night sky belong to a small local bubble surrounding us, less than 1% of the galaxy's total size. The rest of the Milky Way remains distant and largely unseen, obscured by dust and vast distances that even light struggles to cross. The Milky Way is not just a static structure, it is a cycle of continuous transformation. In the spiral arms, clouds of gas collapse under gravity to form new stars. Elsewhere, aging stars explode as supernovae, scattering elements like carbon, iron, and calcium into space, the very materials that would one day form planets, and eventually, life itself. We do not merely live in the Milky Way, we are made from it. Pause for a moment and feel this. Close your eyes if you wish, and imagine the massive planet beneath you moving at 220 kilometers per second through the darkness of the galaxy. Why do you not feel it? Why does everything around you remain still, the cup on your table unmoved, your breath steady and calm? Is it because we are too small to perceive the storm we are part of? Or because the universe operates with such precision that even the most immense motion becomes a form of perfect stillness? And yet, even something as vast as the Milky Way is only a small island. When we look beyond its edges, we begin to see other enormous shapes drifting in the darkness. Other galaxies, waiting. Some of them are so large, they seem capable of overwhelming even our imagination. As we leave behind the luminous spiral arms of the Milky Way and move toward its outer boundary, the darkness begins to feel different, deeper, more absolute. This is no longer the darkness between stars, but intergalactic space, a vast abyss where matter is so sparse that it approaches near-perfect vacuum. Looking back, our Milky Way now appears as a solitary whirl of light. But as your gaze stretches farther into the distance, a striking realization begins to emerge. The universe is not empty. It is an ocean filled with countless islands of light, much like our own home. The first major structure we encounter in this darkness is Andromeda Galaxy. Located about 2.5 million light-years away, it is the largest spiral galaxy in our local region. Data up to 2026 suggests that Andromeda is not only larger in size, but may contain up to 1 trillion stars, 2 to 3 times more than the Milky Way. Despite the immense distance, if it were bright enough, Andromeda would appear in our night sky as an object 6 times wider than the full moon. And yet, there is something even more dramatic unfolding. The Milky Way and Andromeda are moving toward each other at a speed of about 110 kilometers per second. In roughly 4 billion years, these two giants will merge, forming a new, larger galaxy. We are not just observers of this process. We are participants in a vast intergalactic gravitational dance. If Andromeda makes the Milky Way seem modest, then there are structures beyond that make even Andromeda feel small. Far in the direction of the Virgo constellation lies one of the largest galaxies ever observed, IC 1101. IC 1101 is a supergiant elliptical galaxy with a diameter of about 6 million light-years. To understand its scale, if it replaced the Milky Way, it would engulf Andromeda, the Triangulum Galaxy, and all the space in between. It contains an estimated 100 trillion stars, a number so large that it stretches beyond ordinary comprehension. If each star were a grain of sand, IC 1101 would hold enough to fill an entire stadium, while the Milky Way would be just a small handful in comparison. It is a realm of ancient stars, dim, red, and aging, where star formation has long since slowed, giving way to a quiet, immense grandeur. But the universe is not limited to spirals and spheres. There are irregular galaxies, distorted by past collisions, and dwarf galaxies containing only a few million stars, drifting like satellites around larger systems. By 2026, observations from next-generation space telescopes have revealed something even more subtle. Even regions once thought to be empty contain thousands of faint galaxies. They resemble particles of dust illuminated by a beam of light in a dark room. Each tiny glow represents billions of stars, billions of planetary systems, and perhaps billions of untold stories. For centuries, humanity has held on to the belief that we are special. We once believed we were at the centre of the solar system, then at the centre of the galaxy, and perhaps even the universe itself. But when we look out at the vast population of galaxies, from the smallest dwarfs to giants like IC 1101, we begin to understand something deeper. The Milky Way is an average galaxy. It is not exceptionally large, nor particularly small, not unusually bright, nor especially faint. It is typical. We exist in what could be described as a common neighbourhood of the universe. The grandeur of the Milky Way that once overwhelmed us now becomes a reference point, a midpoint on the scale of intergalactic space. And within this immense ocean filled with luminous islands, where each galaxy may contain trillions of opportunities for life, have you ever considered that the place you call home, the Milky Way itself, might simply be ordinary? Does that realization feel unsettling, or does it bring a sense of quiet comfort? That we do not need to be at the center to have meaning, that even in our ordinariness, we remain part of something vast, something alive, expanding, and interconnected. Because that very sense of ordinary is not the end of the journey. It is the doorway to something even larger, a structure where galaxies themselves are no longer isolated, but connected into immense cosmic cities. And that is where we are going next, into the domain of superclusters. As we move beyond the isolation of individual galaxies, a deeper pattern begins to reveal itself, a fundamental rule of the universe. Everything tends to gather. Just as humans form villages and villages grow into cities, galaxies are not scattered randomly. They are bound together by an invisible yet powerful force, gravity. Welcome to the next level of scale, where we no longer count stars, but entire collections of galaxies. Let us begin with our own neighbourhood. Astronomers call it the local group. It is a modest collection of around 80 galaxies. Within it, the Milky Way and the Andromeda Galaxy are the dominant giants, while smaller dwarf galaxies orbit around them like satellites. The local group spans roughly 10 million light-years, an immense distance by any human standard. Yet on the cosmic map, it is little more than a quiet suburb at the edge of something far larger. If the local group is a neighbourhood, then about 50 million light-years away, we encounter something closer to a true cosmic city, the Virgo cluster. This is a region dominated by gravity. The Virgo cluster contains between 1,300 and 2,000 galaxies packed into a relatively dense volume of space. At its centre lies massive elliptical galaxies such as M87, home to the first supermassive black hole ever directly imaged by humanity. The gravitational pull here is so strong that it is drawing our local group toward it. We, along with dozens of other galaxy groups, are effectively satellites orbiting this luminous, massive structure. But even the Virgo cluster is only a fragment of something far greater, something that humanity has only begun to map in recent years. Thanks to increasingly precise measurements of galaxy motion, refined up to 2026, we can now identify the broader structure that we truly belong to. It is called the Laniakea supercluster. In Hawaiian, Laniakea means immense heaven. Unlike a simple sphere or disk, Laniakea resembles a vast network of flowing filaments, threads of light stretching across space, converging toward a shared gravitational center. It contains the local group, the Virgo cluster, and hundreds of other galaxy clusters, all woven together into a single system. Pause for a moment and take in this number. Laniakea spans approximately 520 million light-years. For light, the fastest entity in the universe, to travel from one end to the other, it would take more than 500 million years. This means that if an event were happening right now on the far edge of Laniakea, by the time its light reached Earth, our planet might have undergone multiple cycles of extinction and evolution. At this scale, the idea of the present begins to lose meaning. We are only ever seeing echoes of the distant past. Within Laniakea, everything is moving with direction and purpose. Like water flowing downhill, hundreds of thousands of galaxies are gradually being pulled toward a mysterious region known as the Great Attractor. This is a massive concentration of matter, hidden behind dense cosmic dust within our own Milky Way, making it difficult to observe directly. Yet its influence is undeniable. It is shaping the motion of the entire supercluster. Our cosmic home is drifting along a vast gravitational current toward a destination we are only beginning to understand. At this point, a profound realization emerges. The universe is not chaotic, it is structured. Planets orbit stars. Stars gather into galaxies. Galaxies form groups and clusters. Clusters connect into superclusters. Each level introduces new laws, new distances, and new scales that surpass anything our ancestors could have imagined. We do not simply live on a planet. We exist within a layered structure, a vast interconnected network where every component is linked. Pause. Take a breath. Imagine standing at the highest possible vantage point, looking down at the entirety of Laniakea, a field of over 100,000 galaxies, shimmering like droplets of light across a cosmic web. Can you truly comprehend a structure so large that light itself needs hundreds of millions of years just to cross it? When you hear a number like 520 million light years, does your sense of space begin to shift? Do you feel smaller, almost fading into insignificance? Or do you feel something else? A quiet sense of wonder that your mind is capable of even beginning to grasp a structure this vast. And yet, Laniakea is not the end. Beyond it, other superclusters stretch across the darkness, and they do not stand alone. They connect, forming something even greater, a structure that defines the universe itself, the cosmic web. When we step back far enough, beyond even the luminous boundaries of the Laniakea supercluster, a striking truth begins to emerge. At the largest scales we can observe, the universe is not a random scattering of galaxies. It is not a chaotic fog drifting in darkness. Instead, the universe has an architecture, a structure so intricate, interconnected, and breathtaking that scientists call it the cosmic web. If you could rise above everything and look down on the universe as a whole, you might see something resembling the neural network of the human brain, or delicate strands of a spider's web shimmering in morning light. This network is woven from two opposing yet inseparable components, filaments and voids. Filaments are vast cosmic highways, dense with gas and billions of galaxies. They are the regions where matter gathers, where light shines brightest. These strands stretch across unimaginable distances, connecting galaxy clusters and superclusters into a single continuous framework. Between these filaments lie the voids, enormous bubbles of emptiness. Some span hundreds of millions of light years, containing almost no stars, no galaxies, not even dust. They are the deserts of the universe, occupying most of its volume while holding the least amount of matter. Why does the universe arrange itself this way? Why not distribute matter evenly? The answer takes us back to the earliest moments after the Big Bang. Observations and simulations from organisations like NASA, combined with data from the Euclid Space Telescope, updated through 2026, reveal that the cosmic web formed from a long, ongoing tension between expansion and gravity. In the early universe, certain regions contained slightly more matter than others. Gravity amplified these differences, pulling more material into denser areas over billions of years. As matter gathered into filaments, vast empty regions were left behind, forming the voids. But this network is not static. It is alive, in motion. Gas flows along filaments like blood through veins, feeding galaxy clusters at their intersections. These nodes, where filaments meet, become centers of intense activity, where new stars are born and galaxies evolve. The deepest insight offered by the cosmic web is this: the universe is not random. From subatomic particles to structures spanning billions of light years, everything follows consistent physical laws. Matter is distributed with order, not chaos. When scientists map the cosmic web and compare it to neural structures, an unexpected similarity appears. It is as if the universe is organized with a kind of efficiency, where every galaxy is a node, every void a pause in a larger cosmic rhythm. By 2026, astronomers have even begun to directly observe faint, diffuse gas connecting galaxy structures once predicted only by simulations. These discoveries confirm that the universe truly is a vast, interconnected system, a kind of cosmic body in which we are only a tiny, almost invisible part. Take a moment and expand your imagination just a little further. Imagine standing outside this network, looking at trillions of galaxies glowing along endless strands of light. Do you believe this precise arrangement is the result of random collisions over billions of years? Or does it suggest an underlying order we are only beginning to understand? And when you notice the resemblance between this cosmic network and the neural pathways within your own mind, do you feel a connection? Could the universe be something more than a collection of objects? Something closer to a system, a structure, perhaps even a form of existence beyond what we can define? And yet, for all its vastness, even the cosmic web has a limit. It is the boundary of what we are able to observe. Beyond the luminous threads of this network lies a concept that begins to challenge everything we think we know about space and time: the observable universe. And that is where we are going next, into a realm where the edge of reality itself slowly comes into view. After passing through the vast filaments of the cosmic web, we arrive at a boundary where every familiar idea of distance begins to bend under the weight of time. This is the farthest limit human understanding can reach, the observable universe. By 2026, thanks to breakthroughs from the James Webb Space Telescope and next-generation infrared observatories, we are not only seeing farther, but also seeing earlier than ever before. And yet, this journey reveals something unsettling. The universe is far larger than what light allows us to observe. Let us begin with a number that often confuses even the most logical minds. We know the universe is about 13.8 billion years old. Based on simple reasoning, the farthest object we should be able to see ought to be 13.8 billion light-years away. But reality is different. The diameter of the observable universe is about 93 billion light-years. Why does this contradiction exist? Because the universe is not static. During the 13.8 billion years that light has been travelling toward us, space itself has been expanding. The galaxies that emitted that light when the universe was young have since been pushed much farther away. Today, they lie roughly 46.5 billion light-years from us in every direction. This means that when you look at the deepest images captured by James Webb in 2026, you are seeing galaxies that at this very moment exist far beyond the reach of any signal we could ever send. We can see them, but we can never reach them. Within this immense sphere, 93 billion light-years across, scientists estimate there are about 2 trillion galaxies. Take a moment and try to grasp that number. 2 trillion. If each galaxy were a single sheet of paper, the stack would stretch from Earth to the Moon and back again dozens of times. And within each of those galaxies are hundreds of billions of stars, each one potentially hosting its own planetary system. In its latest observations, the James Webb Telescope has even detected galaxies that seem to appear too early, massive, luminous structures that formed just a few 100 million years after the Big Bang. These are like fossils of light, evidence of how rapidly and intensely the universe began to shine in its earliest moments. This leads to one of the most important insights of all. In the universe, looking farther means looking deeper into the past. When you look at the moon, you see it as it was 1 second ago. When you look at the sun, you see it as it was 8 minutes ago. When you observe stars in the Milky Way, you see them as they were thousands of years ago. And when we use powerful telescopes to reach the edge of the observable universe, we are witnessing the universe just as it was in its earliest stages. The observable universe is like a vast museum where every exhibit is made of light. At its outermost boundary lies the cosmic microwave background, the faint afterglow of the Big Bang. It is the final wall of observation. Beyond it is a region of darkness, where light has not yet reached us. or where space itself is expanding so rapidly that those regions are forever beyond our sight. We live inside a bubble of light. With every passing second, light from more distant regions reaches us, expanding this bubble slightly. But at the same time, the accelerated expansion of the universe is pushing galaxies away, faster than light can bring their signals back. At some point in the far future, all galaxies beyond our local group will disappear from the sky. Future civilizations will look up and see only darkness, never knowing that a universe filled with 2 trillion galaxies once surrounded them. We are living in a rare moment, a moment when the universe is old enough to have formed intelligent life, yet young enough for us to still observe its history. Pause for a moment and look into the dark space between the stars. Do you realize that you are not truly looking into space, but into history? Every photon reaching your eyes right now may have begun its journey billions of years ago, traveling across vast cosmic structures just to carry a message from the past. When you understand that you stand at the center of a sphere containing 2 trillion galaxies, and that every second you breathe, new light from the most distant regions is arriving, do you feel the weight of that presence? We are, in a very real sense, time travelers through observation. And yet, everything we have just seen, those trillions of stars and galaxies, may only be a small fraction of what truly exists, because the most dominant component of the universe is something we cannot see at all. Now, we begin to face the darkness. We have come a long way together, from grains of sand on Earth, through radiant megacities of galaxies, all the way to the edge of the observable universe. By now, you may feel overwhelmed by the sheer scale of trillions of galaxies shimmering in the distance. But this is the moment we must face one of the most shocking truths in modern science, a truth that can challenge everything you trust your eyes to see. Everything we have just explored, the sun, the planets, billions of stars, magnificent spiral galaxies, and even your own body, represents only a tiny fraction of the universe. All of it accounts for just about 5%. Imagine watching a puppet show. You see the figures moving gracefully on stage, but you cannot see the strings controlling them, nor the hands behind the curtain. That is how we discovered dark matter. From the late 20th century to the most precise observations up to 2026, especially from missions like the Euclid Space Telescope, scientists noticed something unusual. Galaxies are rotating too fast. Based on the visible matter we can observe, gravity should not be strong enough to hold them together. The stars should have flown apart long ago. Something unseen, massive, and invisible must be surrounding these galaxies, providing the extra gravitational pull needed to keep them intact. This substance does not emit light, absorb light, or reflect light. It passes through your body, through the Earth itself, like a ghost. Dark matter makes up about 27% of the universe. It is the invisible framework, the scaffolding, on which galaxies are built. Without it, the cosmic web we explored earlier would collapse, and the conditions necessary for life would never have emerged. If dark matter is the glue that holds the universe together, then on larger scales, there is an even more powerful force pulling everything apart. This is known as dark energy. In 1998, scientists made a startling discovery. The universe is not only expanding, the expansion is accelerating. Some unknown form of energy is pushing galaxies away from each other faster and faster. Unlike matter, this energy does not gather in one place. It exists everywhere, embedded in the very fabric of space itself. The more space expands, the more dark energy there is to drive that expansion further. As of the most accurate measurements in 2026, dark energy accounts for about 68% of the total energy density of the universe. It is the dominant force shaping cosmic evolution, gradually overpowering gravity and driving the universe toward a future of increasing isolation. At this point, we must shift our perspective. We are used to believing that seeing is believing, but in the universe, what we see is only the surface of a much deeper, darker ocean. The ordinary matter that forms stars, planets, and life is just a small deviation, a minor fluctuation in the total energy of existence. We live in a universe governed by invisible forces. Dark matter builds the structure, dark energy stretches it apart. And as of 2026, science is still searching for the true nature of these two dominant components. We know they exist through their effects on light and motion, but we have never directly touched them. The universe continues to hide its deepest secrets in absolute darkness. Look at your hand for a moment, then look out into the space beyond your window. Everything feels solid, real, certain. But right now, billions of dark matter particles may be passing through every cell of your body, and you would never notice. And the empty space between you and the stars may be filled with an energy so powerful it can pull apart even the largest superclusters over time. If 95% of the universe is invisible, and your senses can only perceive the remaining 5%, can you still trust what you see? Or is the reality we experience only a thin layer floating above something far greater and far more unfamiliar? When we begin to understand the dominance of this invisible darkness, we no longer see ourselves as the center of the universe. We become something else. Observers, visitors, trying to read a book where most of the pages are written in invisible ink. And yet, it is this darkness that leads us to the final question. Where does this journey go next? Does the universe have a limit? And what kind of future lies beyond the horizon we cannot see? Our journey has taken us from grains of dust in the palm of a hand to the outer edge of the largest structures the human mind can comprehend. But at this final stop, we are no longer looking at what exists. We are looking at what will be lost. This is the closing chapter of a cosmic story, where we confront the ultimate limits of physics and the long-term fate of everything that exists. The universe is not only vast, it is changing in a way that no future technology may ever reverse. We often imagine a distant future where humanity explores faraway galaxies, but there is a fundamental barrier known as the cosmic horizon. It is not a visible wall, but a limit defined by speed and time. As we have seen, dark energy is driving galaxies apart at an accelerating rate. At a certain point, the distance between us and distant galaxies will increase faster than light can travel, and this leads to a profound consequence. Light from those galaxies will never reach us again. They will slip beyond our observable horizon, like ships disappearing over the edge of an ocean. Even if you had a telescope 1 billion times more powerful than the James Webb Space Telescope, you would see nothing but darkness in their direction. The galaxies you see in NASA images today, as of 2026, are already on their way out of reach. Modern physics teaches us something difficult to accept. The limits of humanity are defined by physics, not by technology. Even if, millions of years from now, humanity develops engines capable of bending space itself, we may never outrun the expansion of that space. The universe is gradually pulling itself apart. Within about 100 billion years, all galaxies beyond our local group will disappear completely from view. The night sky of distant descendants will be different. They will see only a few faint points of light, remnants of nearby galaxies that have merged. To them, the universe will appear small, quiet, and empty. They will never know that, in 2026, their ancestors once observed a vast cosmic web filled with trillions of galaxies. We are living with a rare privilege, one that time will eventually take away. The far future of the universe unfolds across eras so immense that ordinary measures of time lose meaning. The stelliferous era, the age of stars, is the one we live in now. It is a time when stars continue to form and shine, but it will come to an end in about 100 trillion years, when the last reserves of hydrogen are exhausted. The final stars will fade, like candles slowly going out in an ever-expanding darkness. After that comes the degenerate era, where only the remnants of stars remain: white dwarfs, neutron stars, and black holes. Then, the black hole era. At this stage, black holes become the dominant structures in the universe, but even they are not eternal. According to Hawking radiation theory, black holes slowly lose mass and eventually evaporate. After approximately 101010 to the power of 1001010 years, a number with 100 zeros, the last black hole will disappear, releasing a faint final flash of energy. And beyond that, the universe enters what is known as heat death. No energy gradients, no motion, no change. Time itself loses meaning. The universe becomes an endless expanse, approaching absolute zero, where particles drift apart across unimaginable distances. The universe began in a brilliant burst, and it may end in a quiet, fading stillness. And yet, we exist somewhere in between. We are not too early, living in a chaotic plasma, and not too late, staring into an empty sky. We exist at what might be called a sweet spot in cosmic time, where the universe is both visible and understandable. Pause for a moment. Do you realize that we may be living in the best possible era to observe the universe? If you were born hundreds of billions of years in the future, everything we have explored in this journey would be gone, unseen, unknown, perhaps even unimaginable. Every image returned by the James Webb Telescope, every number we measure, is something time is slowly taking away. When you consider the scale and fate of the universe, does each moment begin to feel more significant? Every second you are alive, every photon reaching your eyes, carries information from across vast stretches of space and time. The universe may be too large to fully comprehend, but it is still generous enough to reveal its beauty to us before the darkness closes in. And for now, we are here to witness it. Our journey from tiny grains of dust to the edge of the observable universe comes to a gentle pause here. Many people say that when they look at the vastness of 2 trillion galaxies, or the cosmic web stretching across billions of light years, they feel small, even insignificant. But Space Lull invites you to see it differently. You are not small. You are simply looking at something immensely large. In truth, you are a remarkable outcome of probability. For you to be here, listening, reflecting, and contemplating the scale of the universe, it took about 13.8 billion years for the cosmos to forge the atoms within your body. You are not separate from the universe, observing it from the outside. You are a part of the universe, becoming aware of itself. The calcium in your bones, the iron in your blood, were created in the final moments of massive stars. Those elements have gathered over time to form something extraordinary, your consciousness. We are living in one of the rarest and most precious moments in the history of existence. A moment when light still travels freely enough to tell the story of the past, and space has not yet expanded so far that it hides the distant neighbours from view. You are among the few beings granted this privilege, to see and to understand. Now, allow your body to relax. Let the billions of years, the superclusters, and the invisible darkness slowly drift into the background. The universe remains out there, vast, quiet, and precise, unfolding in a way that has allowed life to exist safely on this small blue planet. If you are still here, listening to these final words, Space Lull would like to offer you a sincere thank you. In a world that moves so quickly, thank you for taking this moment to slow down, to reflect, and to appreciate the quiet beauty of existence. Before you drift into sleep or return to your day, would you share something with us? Where are you listening from on this earth? And what time is it right now where you are? Leave a comment, a small signal, a quiet greeting between fellow travellers in this vast ocean of space, wishing you a peaceful rest and dreams that reach beyond the horizon of the universe. Good night, and we'll meet again in the next journey with Space Lull.